Very good morning to all of you. So, yesterday we were dealing with how to use chain rule or base changing rule in differentiation, and after doing that we introduced integration, which I said is the reverse process of differentiation. So, if we differentiate something, means we are getting the rate of change of something with respect to some other variable. Like if we are writing dy by dx, we are finding the rate of change of y with respect to x at any particular value of x, right? So if you want to retrieve y, means you found the rate of change of y, you got dy by dx. Then if you want to retrieve or again get back y, so what you do for that, you need to integrate the rate of change. Like I said that if you differentiate position with respect to time or displacement of a particle with respect to time, you get the velocity at any instant. That means if you will integrate velocity with respect to time, you are going to get displacement or change in position, right? Similarly, if you differentiate velocity, you are getting acceleration if you do so with respect to time. So if you integrate acceleration, definitely you are going to get some velocity. So this integration, how it is represented, we saw the form, and then we saw 2-3 important integrals, just I said by the reverse way, that if you integrate sin x, you are going to get minus cos x. When you are going to integrate cos x, you are going to get plus sin x. When you are going to integrate x to the power n, where n is not equal to 1, then you are going to get x to the power n plus 1 by n plus 1. Now in all these integrations, one thing I wrote an extra term. If you had seen last class, I wrote integration is equals to some value plus constant c. I call that constant as an arbitrary constant. Arbitrary constant, when the word arbitrary comes, arbitrary means it can be given any value. As per a situation, it can take any value. So when we write, suppose if you integrate any function of x with respect to x, if you integrate any function of x with respect to x, you write it in this format. That means you are integrating fx with respect to x. We write, suppose this is equals to a new function, let's call it as capital. Just giving a name. I'll show by example also. Don't be in a hurry that, sir, what is this, what is that. This, if suppose it is a function, then we say that along with it we attach a constant on the right hand side of the equation. RHS, we are putting a constant. This constant is called as an arbitrary constant, which can take different values according to different situations. So when we have this form, the integration complete value is not known to us. The complete value of the integration is not known to us. Why? Because you are getting this function of x, new function of x, but you are also getting an arbitrary constant whose value can be anything. So this type of integration, when you write like this, the complete value is unknown. It is called indefinite integration of the function fx with respect to x. And what is the reason? Who is the culprit who is not giving it the complete value? It is c. If the value of c is known, then you will get complete value. Indefinite integration of fx with respect to x. Since its complete value is not known due to the arbitrary constant c. Now in this we have seen examples which I am again writing. If you integrate cos x with respect to x, you get sin x plus c. When you integrate sin x, you get minus cos x plus c. When you integrate x to the power n, you get x to the power, increase the power by 1 and divide it by the increased power. X to the power n plus 1 by n plus 1 plus c. Only remembering what I told yesterday, n should not be equals to minus 1. Because if n becomes equal to minus 1, then this can be written as 1 by x, that is dx by x. So when you write this, you get natural log x plus c. So if x to the power minus 1 comes, means n is minus 1, you cannot use this formula. Don't say, sir, why can't we use this? You cannot. It will be this. Why? Because we know when we differentiate natural log x plus any constant, then we get 1 by x. Constant differentiation is 0, so we get this. So that's why whenever we have natural log x differentiation, we know it is 1 by x. So whenever we have integration of 1 by x, you get natural log x plus c. All these forms which I have written over here, these are examples of indefinite integration, because I don't know the value of fx completely. And what is this small fx and capital Fx? You can see small fx is a function of x, which I have written here. Capital Fx is another function of x, which I have written on the right hand side. Like cos x is small fx, capital Fx is sin x. Just to show these two different functions, we are using the name small f, capital F. These are functions. Next, to add to the list, I have already told, if you have differentiation of tan x, it is sec square x. So if you have integration of sec square x with respect to x, it will give you tan x plus c. If you have cot x, you know it is minus cosec square x. So if you have cosec square x, you will get minus cot x plus c. And one more important, if you have e to the power x, we had seen e to the power x integration will be same as e to the power x, because differentiation of e to the power x is also e to the power x. So you write e to the power x plus c. These are the important formulas, basic formulas which everyone should remember regarding integration. These all formulas, so you have to remember. Only thing you have to be careful is arbitrary constant. As it is an arbitrary constant, it can take any value. Whenever we are writing integration, final constant we are writing on the right hand side. When we write that constant on the right hand side, it is anything. This constant plus constant or multiplied by constant divided by constant is a constant only. So don't be bothered that, sir, c by 2 came, what should I write? Arre, take c by 2 also as c. C by 3 also as c. 3 into c as c. C plus c also as c. This is a constant. So when you are using constant, constant plus constant, constant minus constant, constant divided by constant, it will be constant only. So you will just replace it by arbitrary constant. So this much, is it clear to all of you? I hope. So let's see some examples, and just like differentiation, there are lot of rules for integration. I will say unlike differentiation. Differentiation can be done orally. For very large differentiation also you can do it very fast. But for integration, it is a highly conceptual thing. But for physics, we have limited scope of integration. Few rules are there which you need to know. Few formulas are there which you need to know. So what all are required for you to solve any question of physics, whether it is for NEET or for JEE, you have a list of formulas and a handful of rules which you have to follow. So I am going to write that. This one, if you wish, you can take a screenshot, and otherwise you know very well that in every class I tell that in YouTube you can later pause the video and you can make a note of it. Okay. Now, if you talk about rules of integration, First thing I discussed yesterday with a problem also. Whenever we have just dx, it means you are actually integrating x to the power 0, because x to the power 0 is nothing but 1. So integration will become what? X plus c. If you have integration dy written, you can write y plus c, etc. Second, if you are integrating any function fx with respect to x and some constant is multiplied here, let's take the constant as k. So you can take that constant outside the integration like this, and suppose this integration comes as capital Fx plus c. So this constant is to be, if constant is multiplied, you can directly take it outside. Example, if you see, three sin x dx, you will take 3 outside, integrate sin x. Sin x integration we know is minus cos x plus c. So you will get minus 3 cos x plus c. If you are writing integration 3x square dx, so you know 3 will come outside, x square integration x to the power n plus 1 by n plus 1 plus c. So you will get 3 x cube by 3, so 3 goes away, so you are left with x cube plus c. If you are given like this, 2 by root x, what you can do, take the 2 outside, root x denominator means you can take it up, x to the power minus 1 by 2, because root means x to the power 1 by 2, if it goes up it will become x to the power minus 1 by 2. So from here you can write 2, integration power will increase by 1, and in denominator also you have to increase by 1 plus c. Now see what will happen, minus 1 by 2 plus 1 is plus 1 by 2, 2 goes up becomes 4. This is x to the power 1 by 2, which is nothing but root x plus c. So these are some examples which I have shown that how any constant, if it is present with the function and it is multiplied, what you need to do, you directly need to take that outside. Now sometimes, just to make this thing clear, no one should have a problem like this later. So these are examples which I am taking over here. One more example just like this. If you are suppose seeing an integration 3, I have repeated lot of time, let's take like this. Suppose like this. So that means here 1 by 4 will be outside and you will be left with integral dx, which is we know x plus c. So you will write x plus x by 4 plus c. Don't say, sir, what happened, you wrote x plus c, c by 4. C by 4, constant by 4 is a constant, you will always write as constant c only. So just this way we can find the integration of functions where a constant is multiplied. Is it clear to all of you? These basic rules first we are discussing. Now let's see what all other rules we should know. Is it clear? Okay. Next, third rule. If you see several functions are added or subtracted, whatever it can be added or subtracted inside the given integration. This simply means you have to take individual terms separately. So every time now you need not waste time in breaking the bracket. What you are going to see is you will write each term separately and integrate them. So as an example, if you have like this. So what you need to do, you just need to integrate separately. X to the power 4 separate, 2 dx upon x separate, just dx is multiplied to each one, 4 sin x dx separate, then plus 2 dx. That's it. Now you can write it x to the power 5 by 5. Integration 1 by x we have seen is natural log x. Sin x is minus cos x. And just dx comes means x. And you have to put at the arbitrary constant c at the end. So our final answer comes of the form x to the power 5 by 5 minus 2 natural log x plus 4 cos x plus 2x plus c. So when we have multiple functions being added or subtracted, so you can directly find in this particular way. Is it clear to all of you? So addition, subtraction, these rules are very simple. So we have to go through few rules only, because as I told earlier that it is not possible that you remember all the rules of integration. Integration for JEE it is mainly taught in detail. For NEET we don't have, and for JEE also not in physics but in maths we have to study integration in detail with lot of rules, lot of important concepts are there. But for physics, even in JEE also, limited knowledge of integration is sufficient. So how we have to use that, we are seeing the rules. Third rule is also mentioned over here. Next important thing, sometimes you will see that instead of e to the power x, they will give you a to the power x integration. They will ask you what is the integration of a to the power x, where a is any constant. So if they give you a to the power x, so it is found just like e to the power x, but what happens, it uses the concept of logarithms. So a power x integration, if it was e to the power x, you know e to the power x, same you will have a to the power x. Only that this term gets divided by natural log of a. So when you integrate, natural log of a needs to be divided plus c. For example, if they ask you or you are seeing something like this, integration 2 to the power x. So you will say it is nothing but 2 to the power x by ln2 plus c. ln2 value I have already told, 0.693 or 0.7, like this. So instead of e to the power x, if you are seeing a to the power x, the integration is to be written as a to the power x by ln a. In differentiation, if you see a to the power x, then it comes as ln a multiplied by a to the power x. Understood? For differentiation, a to the power x differentiation is ln a multiplied, here it is divided. This is very important rule, remember this. Next, we have, suppose you integrate any function, this is called integration by substitution. If you integrate any function and suppose you are getting capital F as a new function, small f was a function, you integrated it, you got capital F, suppose. Then if x is replaced by a linear function of x, instead of x, if I have ax plus b, linear function, then if you integrate this, you are going to get the same function capital F. You are going to get the same function capital F. But here you don't have x, you have ax plus b. So as it is, you will write, what you will write, function of ax plus b. But whatever is divided to x here, it needs to be divided here. Means the coefficient of x needs to be divided, plus whatever was the constant. At first glimpse, most of the students, either they don't understand or they get slightly disturbed by whatever is written. But when you take example of this, this becomes crystal clear. Let me show you what I am trying to mean over here. Examples. So focus first here, how this came, how that came, everything comes by substitution rule and all. How we write this thing, like we know, if I am giving integral cos x, you will say, what is the answer? Sir, answer is sin x plus c. Very good. So if they say integral cos 2x plus 3, so you will see cos ka integration sin, cos ka integration you will write sin, means small f was cos, capital F is sin. So small f cos, capital F sin. You are integrating 2x plus 3, in place of x you have a linear function 2x plus 3, linear. So here also you will write 2x plus 3, done. Now comes the division part. Whatever is multiplied with x, that you have to divide, means the total will be divided by 2. And what extra you will be left with? C. If you see another example, suppose I am given sin 3x. Sin 3x. What I will do, simply I will write sin integration is minus cos, so I will write minus cos, but we have 3x, not x, so 3x. What is multiplied to x? 3, so you will divide also by 3, plus c. If you see forms like 1 minus 2x whole to the power 4, like this, just see, means instead of x you have a linear term, ax plus b form. 1 minus 2x power 4 is there. So think what we know, if it was x to the power 4, what would be your answer? You will say, sir, x to the power 4, so I can write x to the power 5 by 5, exactly. So here, if you write x to the power 4 as x to the power 5 by 5, this means, if I am writing 1 minus 2x power 4, it is also a linear term in x. You will use the same 1 minus 2x power 5 by 5 plus c. Now you will say, sir, it is incomplete, you have not written something else. Yes, I have not written something else, now I am going to write. Here, after writing this form, exactly same, I am seeing something is missing. What is that? What is being multiplied to x? See the coefficient properly. The coefficient is minus 2. So minus 2 you have to divide. Minus 2 you have to divide. So basically when you do so, it will become minus 1 minus 2x to the power 5 by 10 plus c. So whenever we see any function which is given as a function of ax plus b instead of x, they have given ax plus b where a and b are constants, then you will do the same integration or use the same formula which you use for fx. But after writing that, you have to divide the coefficient of x. Mind it, this is only to be used for linear functions. If in place of ax plus b you have quadratic or cubic or something else for x, don't use that. So x should be replaced by ax plus b. So that coefficient simply needs to be divided. Please make a note of this fast. Yes, correct. Okay, fine. Another example using the same, if suppose we had e to the power minus x. Now see here, e to the power minus x. If you are writing e to the power minus x, what is the value? If it was e to the power x, you will write e to the power x. So here also you will write minus x. Now you have to divide by what? What is multiplied to x? Minus 1. So you will divide by minus 1 plus c. Means your answer will become minus e to the power minus x plus c. If you had e to the power 2x dx, you will write e to the power 2x by 2 plus c. That's it. If you had Sujata, your friend Comedy Stars have left the classroom, or sorry, he has been removed from the classroom and he has gone to his school to do comedy. I am sending you also over there. I think you are also not interested in studying. You are more interested in seeing where your comedy friend is. Go with him. Okay. Okay, Sujata, you need to learn. You better fine. So let's see. If we have like this form, integration, you will see dx by 2 minus 3x. So what you will say? Now we know if you just have dx by x, it is natural log x plus c. So if you see the form ax plus b, you will again write natural log ax plus b. Whatever is multiplied to x, that coefficient you have to divide, plus c. So we can say, if we are asked dx by 2 minus 3x, you will write natural log 2 minus 3x divided by minus 3 plus c, which can be then written as minus 1 by 3 natural log 2 minus 3x plus c. Okay, so these are some important forms which you can see I have written over here. So this is to be remembered, these forms. Now what you are seeing in all this is that the differentiation or integration that we have studied till now, we are going to use it in physics obviously, but here the integration is incomplete. Why it is incomplete? Because you can see that the value of c, arbitrary constant, is not known, and without knowing it you cannot get the full value of integration. That's why I called this integration as what? Indefinite integration. So if you want to get a definite value, a fixed value, that means you should know the value of c. So that particular c is obtained by another method which is called as definite integration. So moving to next, what we call as definite integration. So when you integrate any function in a particular range of values, and if particular range of values is given and you want to integrate in that range of values of x, then you get a fixed value which is called as definite integration. If you are writing indefinite integration, you won't get the complete value. But if you write the value, someone is again troubling, I think continuously, let's hear the doubt. Sir, in last question 1 minus 2 is minus 1. The coefficient of x will be minus 1. I did not get you. Which question you are talking of? 1 minus 2 is minus 1. Where you are? Where is 1 minus 2 is minus 1? This is e to the power minus x. Coefficient is minus x. Divide by minus 1. That hangama gaming, what you are doing or what you are up to, I could not get you. Very sorry for that. Let's move. So here, definite integration, limits are applied. Yes, correct. Limits are applied means when we are giving boundaries that we have to find the value from this value of x to this value of x, then you get definite integration. So this is gives a fixed value of integration it is always performed just like indefinite integration, always performed in between two values of x. If you are writing integration between two values of x which are called its limits, these are called as its limits. Now when you use definite integration, there is no role of c after that. No role of c. So c gets removed. Integration formula same as indefinite. Whatever you are writing, same formula you will write. So when we try to write example, if I am saying suppose we write like this, then that was indefinite, definite integration of the same function fx with respect to x in between the limits or interval x is equals to a to x is equals to b. Suppose I am taking two values a and b, yes, is expressed as, you will write the same expression, but now whenever we have limits, we will put the limits of x like this. This a will be called as the lower limit, this will be called as the upper limit. Whichever interval you are finding, the integration, you have to integrate in that particular limits only. So a to b. Now on the right hand side, what we do, as I said, there is no role of c now. Right hand side, whatever function you got in indefinite integration, exactly you will write that. Then the format of writing, it is a format or way of writing, this function is written and you will put one by one the values of x over here. First always we put the upper limit, means first you will put x as b and then you will put x as a. So whatever function you got, you will integrate it first, then whatever final function you are getting, in that first put the upper limit, b, when you are integrating from a to b, b is called upper limit, a is called lower limit of integration. So this is the lower limit and this is the upper limit. Upper limit and lower limit, how to put format? First the upper limit value you will put wherever you see x, put b. Then in the lower limit also wherever you see x, put a. So when we express an integration in this form, then guaranteedly you are going to get some values. That value of integration may be different for different limits. If you keep on finding the value for different blocks or intervals of x, you will get different values, but you will get definite values. Fixed values in that particular limit you will get, that's why it is called definite integration. You are going to get a definite value which is fixed for that given interval of x. Clear? So let me show you by example that how definite integration is the same as indefinite integration, only that you are now getting some values. Example. So if you go by examples, let's start with the basic ones. For example, if I just have dx given like this, just like this, you will say, sir, we to know, if you are writing dx, we know it is x. Now don't say x plus c, that's c gone. Integration dx means integration of x to the power 0, which is x. Yesterday also I told, means 1. When you are integrating 1, you are getting x. Now you have to put the limits one by one. So first you will put x as 5 minus, now you will put x as minus 2. So 5 plus 2, which will become 7. Correct. Now suppose same thing goes and I put x square dx minus 2 to 5. Now what will happen? You will say, sir, x square, so I know x cube by 3. Then you have to put the limits as minus 2 and 5. 1 by 3 outside is as it is. First you will put 5 in place of x. Wherever you had x, you will put 5. Now in place of x, you will put minus 2. Power is 3. You can see x cube, so minus 2 ka cube. Now, when we write 5 cube, 125, minus 2 cube is minus 8. Minus 2 cube is minus 8, but there is one more minus, so plus 8. So this becomes how much? 133 by 3. If you had, say, x dx between minus 1 to plus 1, then what would happen? You will say, sir, x is x square by 2, minus 1 to plus 1, 1 by 2 as it is outside. You will say, first I will take, sir, 1 ka square, minus, now I will take minus 1 ka square. So what I will get is 1 minus 1 ka square is plus 1, you will get 0. If you think that, sir, is this a fixed value for all values of the limits? No. If the same I will put for any other limit, suppose I change it from 0 to 4, then in this range or this interval you will get a different value of the same integration, because x is x square by 2. You will integrate it and then use the limit 0 to 4. So 1 by 2 common outside. First you will take 4 ka square minus 0 ka square, 16 by 2, 8. So if you are changing the limits, you can see that you will get new values. You will get new values. Understood? One more example, first the basic ones. If I take integration sin x 0 to pi, pi means 180 degree. Now I am giving a range. I will say sin x integration is minus cos x, very good. Sin x is minus cos x, minus outside. Now I will put 0 and pi, let's see. So I will put minus, first I will put cos pi, then minus cos 0. Now I have told you already in trigonometry, pi means 180 degree, cos 180 is minus 1 and cos 0 is plus 1. Minus 2 minus plus 2. So when you are integrating sin x from 0 to pi, you are getting the value as 2. When you are integrating sin x from 0 to pi, you are getting 2. But if you do the same for cos x, you will see that you won't get 2, instead you will get 0. Why? Let's see. If the same integration I would have performed for cos x from 0 to pi, then I would have got cos x integration is sin x 0 to pi. So first I will put sin pi, then I will put sin 0. Now sin 180 is also 0, sin 0 is also 0, you will get 0. Did you understand this? Is this clear to all of you? I am taking basic examples, that how first you should know that there should not be any mistake in taking the limits. Okay, fine beta. Let's see. If I take other example, suppose I have forms like this. like this. Now I am making it a bit big. So here when I think we were doing very well today, very less distraction, but here comes another Hazrat Sheikh. Remove him fast. Whenever fertile lands are left or a garden is left untouched for 2-3 days, suddenly you will see weeds will start growing. Okay, those plants need to be thrown immediately, otherwise the entire land will become barren. Nothing will be cultivated over there. Okay. So -2 to 1. What we do? First you will say that's a normal integration. I have already told x square. X square will become x cube by 3. There is 2 also. So 6 minus x to the power 4 we know, x to the power 5 by 5. Now I am directly writing in one line. X to the power 4, 5 by 5. But there is 4 more to 20. Next term 3. 3 dx I said 3 dx will become 3x. This much of by integration first everyone will get. No need of writing that c. Then here we have -2 to 1. Now what you will do in such cases, beta, when you have this forms, just either you can put in every term individually or you can take the whole minus then the lower limit. Whichever suits you, you can do that. So see what I will do here. First I will take 1 by 6 x cube. First you will put x as 1 cube. Then you will put x as -2 ka cube. Always upper limit minus lower limit. Now comes next term. X to the power 5. 1 to the power 5 minus -2 to the power 5 whole divided by 20. Next 3 outside. X you will put as 1 minus x you will put as -2. So when we do that, 1 cube 1 -2 cube Naga Jatin, remove him. -2 cube -8. So you have 1 minus of minus plus 8. 1 ka power 5 is 1. -2 power 5 is -32, but here we have one more plus 32 by 20 plus 3 1 plus 2 3. So you get 9 by 6, which can also be written as 3 by 2 minus 33 by 20 plus 9. Now you can take the LCM also. If you take the LCM as 20, so here we have 2 10s are 20, 30 minus 33 and plus 180. 180 plus 30, 210. So, or directly 180 minus 3. This will be the answer. What will be the tan pi square? What is this? I did not get your question. Sorry, I did not get your question. What will be tan pi square or tan pi 2? Please make it clear. I cannot understand your question. Okay. Now, this type of forms you saw. Sometimes you will see e to the power minus x 0 to infinity. You will say, sir, e to the power minus x is e to the power minus x. Since minus 1 is multiplied, so you will divide minus 1. This we have already seen. Now the part comes is putting the limits. So first you will put x as infinity. So you have minus x, so minus infinity. Then you will put x as 0, e to the power 0. division is -1. Now I have told you about e to the power x also. You can see the video where we had discussed different functions and their graphs. E to the power minus infinity is nothing but 0 and e to the power 0 is 1. So -1 by -1 will become +1. Beta, answer in decimals we should not write, sir. If you know very well, you are going to write NEET exam in which you have 4 options. If you have 4 options, and you will see whether they are asking decimal or not. Gujjala Charanya is asking, sir, what is tan while doing the problem integration pi and down is 2. Everything cannot be integrated in every limit, beta. Remember this. If you do the integration of anything, it won't be valid for all limits. I have lot of problems like that where you cannot integrate. Okay. Presently we are discussing for NEET, but if any time possible, if you are over here, you can come. I will, as much depth you want to go for integration, I will go and show you that every integration in every limit is not possible. There are many restrictions. And then we have to break integrations into different parts also. Right now we are doing the basics. When we find integration, integration can be broken into parts also. There are multiplication rules and all, everything are there, lot of things are there. Presently just focus on the basic rules and what questions can be framed on that. Many times we cannot find the value, a finite value cannot be always found. So here e to the power minus x, this is what we do. Sometimes you will get integrations like integration of tan x, but you will say that, sir, tan x, how to integrate? There it can be solved. Integration of tan x will come in terms of log. They're using substitution, we write sine by cos, take cos as something y or something, then sine will become its derivative. We can solve that. There are a lot of things, Eilert rule and everything are there. But what is necessary for you, that is being taught over here. Understand first that what is important for us for physics, for NEET, what all formulas are to be used, that's what we'll be using. Just knowing a handful of names or this rule, that will not help. Lot of things are there which are beyond the scope of syllabus. We have to cater to the entire class, not a single or 2 students. So it is not possible that everything can be discussed over here. If anyone has their personal doubts of whatever you think, or you can imagine that this can be done or not, when you are in person, come, be my guest, I will definitely tell you how to do that. So here e to the power minus x integration is e to the power minus x by -1, and when you put this particular limit, you get it as 1. Now I will end with 2 important things more. What is that? Sometimes you will see integrations like sine square or integration of cos square comes. These 2 important trigonometric expressions will appear in physics, don't worry about that. I'll tell you names also in the beginning. There is a chapter called simple harmonic motion, there is waves, there is a chapter called electromagnetic waves, there is a chapter called alternating current. There you will see integrations coming of the form sine square and cos square. So which all will appear, we are discussing them first. So sine square x dx and cos square x dx, and everything will be done within what we have already seen. Now if you remember, when we did trigonometry classes, that time when we did trigonometry classes, then what we do in such case, sine square and cos square, if you saw, I said an important substitution, sine square x can be written as 1 minus cos 2x by 2. And if you remember, I have said cos square x is equals to 1 plus cos 2x by 2. Remember this? So if we know this, then whenever you will see sine square x integration coming, what you have to simply do is transform it. This is called transformation method. you can transform it. Sine square you can write as 1 by 2 minus cos 2x by 2 dx. Now simple, first 1 by 2 dx. 1 by 2 dx means x by 2 minus, again we have 1 by 2 common, cos integration I told is sine, but it is cos 2x, so sine 2x, whatever is multiplied to x will get divided. Today we had discussed this rule in the beginning. Since we are putting indefinite, so we will write plus c, so it will become x by 2 minus sine 2x by 4 plus c. Similarly, when you have cos square x, same way you will just write 1 by 2 plus cos 2x by 2 and only minus becomes plus here, so you get x by 2 plus sine 2x by 4 plus c. Yes, so here you are getting minus and here you are getting plus. So these are two important formulas which is obtained by transformation of sine or sine square or cos square, and this is how we get these integrations. If they ask you with limits, you know you can put the limits and upper value limit first minus lower value limit second. Okay. So now in next class we will see how we can apply these all in integration in physics, and gradually when we will proceed with the chapters, then we will see that where there are integration broken into different ranges or different intervals, how to solve them and all, lot of things are there, mod values and all, modulus functions, everything is there, we will see all of them. So that will be all for today's class. I hope you got whatever has been taught. So keeping in mind all the students how to write this, you saw this thing. Okay, so that will be all. Thank you.